Welcome to my fourth class of Fourier series. In the previous three classes, I already explained applications, who is invented Fourier series, how to construct a Fourier series, what are the two cases, based on second case, what are the two subcases, everything I explained. And in the third class, end of the class, I have given the flow chart also. Based on that, we are going to consider some problems how to construct a Fourier series. These are the problems they given way in the question paper or model paper like that. The remaining most of the problem already I solved. I'm going to post that in the document problems where in the VTO section. If you want to take that material, you go through it. What are the problems I'm not discussed in my notes? That problem only I'm doing it on the board. Okay. Find the Fourier series expansion of f of x equals pi square by 12 minus x square by 4 in the interval minus pi less than x less than pi. Hence deduce that 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus etc. equals pi square by 12. Deduce part is just to give the particular value of x and then you find out the deduce part. That's very easy. Now that part is easy. But first we have to give a concentrate for the how to construct the Fourier series expansion for the function f of x is equal to what? X square by 12 minus x square by 4 in the range minus pi to plus pi. I told number of times whenever I have to construct the Fourier series for the function, don't observe the function, first you observe the interval. The given interval is in the form of what actually minus pi comma plus pi. Therefore, whenever this is referred to what based on my class is second case, the given interval is in the form of minus pi to plus pi means minus L to L. Whenever the interval is in the form of minus L to plus L, we have another step get into that, we go for even or odd. First, we have to verify whether the given function is even or odd. First, we have to write what's the given in the problem. Given function interval. Given f of x equals pi square by 12 minus x square by 4 over the interval minus pi comma plus pi. Okay. Now, in the next step, I have to verify is even or odd because is in the form of second case. Is must be is in the form of minus L to plus L. What is my f of minus x? F of minus x is just to replace x by minus x. The constant must be same. Minus of x whole square divided by 4. Minus x whole square, what happened now? X square by 12 minus x square. Once you this is actually pi square, okay, by 4. Now this is after once you replace x by minus x, we get the same function. This is nothing but what type of function? The given function is an even function. For which value 0? Bn is 0. The given function, first I have to write, you must and should have to write these steps, then only I have to write directly Bn is 0. Suppose you are not written these steps properly, simply I have to write Bn is 0, therefore f of x like equal to like that, you are going to lose the marks. Must and should have to write in the proper way. The given function f of x is an even function over the interval minus pi comma plus pi. Therefore, which value 0? Therefore, Bn is equal to 0 and the corresponding Fourier series for f of x over minus pi to pi is, okay. Now while writing a Fourier series for the given function, I told number of times, first you have to know what's the value of L. How to take the value of L here. Now what's our given interval is minus pi to plus pi, okay. Better to use a different color pen. Now here must be equal to the what's the second case of the interval for interval is minus L to L, that implies equal to the upper limit L is equal to pi. L is equal to pi and n pi x by L. What is my n pi x by L is n pi by pi x by pi is cancelled. What's the remaining nx? Now, based on that, we are going to construct a Fourier series. Therefore, what is my Fourier series expansion? Here, f of x is equal to a naught by 2 plus summation n ranging from 1 to infinity a n cos of nx. N pi x by L is nx because L is pi. Yes, okay. In the where what is my a naught? While writing even or odd case, I have to write 2 by L. What is L here? 2 by pi. Sub case of a here 0 to pi f of x dx and also an. What is my an formula? 2 by pi 0 to pi f of x cos nx. I told very clearly after you construct the Fourier series, instead of an what we are going to take f of x cos of nx with respect to x. In the next step, up to this we have take care, the rest of the thing is very easy. Next step I want to find out a naught with the help of the given function. Now I want to find out a naught equals, yeah, what's the formula? 2 by pi, 0 to pi. What is my function here? Pi square by 12 minus x square by 4 with respect to x. Now 2 by pi, pi square by 12 is a constant. Integration of 1 with respect to x is what? X 0 to pi minus 1 by 4 is a constant. What is integration of x square is x cube by 3. What's the limit here? 0 to pi. Yeah. Please do it very carefully. Suppose you have done anywhere mistake, you don't get it correct answer. Now while applying, whenever we are applying a limit, the easiest way is better to keep the constant outside and then apply the upper and lower limit term by term. Don't apply all the term upper limit minus lower limit. Take term by term, upper limit minus lower limit. What is upper limit is pi, minus lower limit is 0. First problem, therefore I am going to write it each and every simple step, minus 1 by 12 of, what is the value of pi is actually pi cube minus lower limit is 0. You simplify that, 2 by pi of, now we get actually pi square into pi is what? Pi cube by 12 minus pi cube by 12. These two are cancelled. We get actually, what we get actually? 0. Yeah, we get 0. A naught is 0. A naught is 0. Next try to find out our an using the function pi square by 12 minus x square by 4. Now an equals 2 by pi 0 to pi square by 12 minus x square by 4 into cos of nx with respect to x. You go for which rule? UV rule is a product of two functions. While taking UV rule, this is nothing but our u function, this is nothing but our v function. Why? Because x square by 12, pi square by 12 minus x square by 4 is 0 after the second derivative. Cosine function is not equal to 0 after the second derivative. From the UV rule, 2 by pi is already I discussed in my first class. First function u is pi square by 12 minus x square by 4 is as itself u into integration of the second function sin nx by n minus derivative of the first function. This derivative constant is 0 minus 2x by 4 into second integral of the given function. We already know the first integral. Again I integrate minus cos nx. Don't simplify that. What we get, you write it inside the bracket. Most of the students, they are doing mistake here. They writing minus into minus plus like that. Don't write it. What we get in the second integral, write it like that. Then easy to carry in the further step. Plus derivative of this function. Second derivative of first function is minus 2 by 4 into, again at integrate, what we get, minus of sine nx by the quotient of x is n square into n is n cube. I think everyone you know how to integrate cos of nx is sine nx by n, because quotient of x, here quotient of x, again we get n square, again we get n cube. Now we are going to start to apply UV rule. Why? Because I told number of times while doing a differentiation, whenever you get a constant, that is the last term of UV rule. Suppose you move to the next further higher term, what happened? Derivative of constant must be 0. In the next step, this can be written as, this must be equal to 2 by pi of, apply the upper limit and lower limit. While applying upper and lower limit, must and should have to take care. Product of any one of the, here in the first term, how many terms are there? 2 terms. Product of any one of the function having sine or cos, suppose you apply the limit. Suppose that function itself is 0, whatever the product must be 0. Again I am going to repeat, while applying the upper and the lower limit, product of any one of the function is sine or cos, suppose you verify that whether it is 0 or not. Is 0 in the corresponding limit, not necessary to simplify the product of another function, because product of one of the functions 0, whatever the entire term must be 0. Here in the first term, the product of one of the function is what? Sine. Apply the upper limit. Once you apply the upper limit, what is sine n pi value? 0. What is lower limit? Sine 0. What is sine 0 is 0. Therefore, while applying upper and lower limit, first try to keep the constant outside. What's the my constant is 1 by n. Once you apply the upper limit, product of sine function, what we get? Sine n pi 0, sine 0 0. What happened? This lower and upper limit must be 0, even though this is not equal to 0. Which one? This is not equal to 0. Product must be 0. This is the easiest way to apply the limits. Please try to understand. Again, I am repeating. This is the first problem. Product of any one of the functions sine or cos. Suppose you apply that upper and lower limit is not equal to 0. You do it further. Otherwise, write it that value must be 0. Before moving to the next step, minus into minus plus, plus into minus is minus 1 by n. What about 4? 2 ones are, if you want to cancel 2 ones are, 2 twos are, what we get? 1 by 2n square is a constant. 1 by 2n square is a constant. Once you keep 2n square outside, before going to apply the upper limit, what's the simplification for this? After the simplify, we get a function x into cos nx. We already taken minus 1 by 2n square outside. Once you take a minus 2n square outside, apply the upper limit. First you know what happened? Cos n pi. Cos n pi is equal to minus 1 to the power of n. And then lower limit. What is the lower limit? Cos 0. What is cos 0? Is 1. Cos of n pi is minus 1 to the power of n. Cos 0 is 1. Then once you apply the limit, what happened? Cos n pi is not equal to 0. Therefore, then we are going to apply the upper and lower limit. X is equal to pi into cos n pi is minus 1 to the power of n minus the lower limit. What's the lower limit? Cos 0. Even though cos 0 is 1, but x is 0, 0 into 1, what we get actually? 0 only. Minus into minus plus, plus into plus is plus. 1 by 2, 2n cube is a constant, not necessary to apply the limit because sin n pi is 0, sin 0 is 0, therefore entire this is must be 0. Okay, this is the easiest way to find out the value of the upper and lower limit. Except this term, every term must be 0. What we get actually? This 2 is cancelled, this 2. What's the remaining? And also pi. Observe carefully. If you want to write once again, suppose you are confusing for that, pi into minus pi by 2n square into minus 1 to the power of n. Now pi is cancelled, 2 is cancelled. What's the remaining now? Minus of minus 1 to the power of n by n square. This is my an. Okay. Once we get n, don't take immediately the next step. First verify for what value of n denominator 0. Denominator, for what value of n denominator n. Why I am worried about n in the denominator n. Once we get denominator is 0, then we get a infinity. But keep in mind, we are expecting n for all values of 1 to etc. must be a finite value. Now, that's why you are not bothered about the numerator, worried about the denominator. For what value of n we get 0, because our summation is ranging from 1 to n, ranging from 1 to infinity. Now, what is denominator factor here? N square. N square is 0, in which case n is 0. But in the Fourier series expansion, if you want, I'll show it once again. For Fourier series expansion, the having a summation is 1 to infinity. Therefore, the least value of n is 1, except n is 0. In the rest of the case, what happens is not equal to 0. Denominator 0, we get infinity. We have to avoid that value. We can't take that infinite value. Only we have consider finite value. Now, confidently say that this n is true for n is equal to 1, 2, 3. How can you know that an is infinity for which value of n means? Once we get an value, pick the denominator. Once you pick the denominator equal to 0, solve that, you find out. For example, here what is denominator n square equal to 0, simplify that, we get n is 0. N is equal to 0 only, we get infinity, but our summation start from what actually 1 to infinity. Therefore, confidently I have to write this is true for n is equal to 1 to 3. This is must be take care while once we get an value or bn value. Okay, no issue. Now I have to substitute these values to construct Fourier series. F of x is equal to a naught. A naught 0, a naught by 2 is also 0. Plus into minus is minus. I'll take minus sign outside. 1 to infinity. Minus 1 to the power of n by n square cos of nx. Cos of nx. Now this is nothing but Fourier series expansion. Now if you want to zoom out a little bit, then easy to know that entire problem. Yeah, in one screen. Yeah, easy to see that this is our problem. F of x is pi square by 12 minus x square by 4, and then minus x square by 4 in the interval minus pi to pi. This is in the form of second case. Therefore, I step into the even or odd. The function is literally is an even function over the interval minus pi to pi. Only we have to construct by using subcase A. And before going to construct, first you have to know what's the value of L. What's the value of L is pi, n pi x by L is nx. Then I have to substitute and simplify that. You find out carefully a naught and n. Finally, we get this is my f of x. But not only I want to find out f of x, they want to deduce this one. Which one I want to deduce? I'm going to write it once again here in the, this is construction of Fourier series over. But we want to do it further. Now, what they're expecting in the problem is, because in the on the screen is not there, therefore I'm going to write this is deduce part. I want to find out 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus etc. equal to pi square by 12 is the thing they expecting. The function is what actually? Function is pi square by 12 minus x square by 4 in the interval x square by 4 in the interval minus pi comma plus pi. Okay, fine. Now here this is Fourier series expansion is over. If they construct Fourier series over. But I want to deduce means I have to choose the particular value of x, try to find out the required deduce part. We can't take opposite manner any value of x. Once you choose the value of x, that value of x must be in the range, give a corresponding interval. What is my corresponding interval is minus pi to plus pi. Now that's a thing we have to take care. Now you compare this to this. Suppose you expand this series. Just I'm going to expand for your reference. Put n is equal to 1. What happened? Minus 1 by n square cos x. N is equal to 1. And then I have to take n is equal to 2. What happened? This is plus 1 by, this is 1 square. This is 1 by 2 square cos 2x and then put n is equal to 3, what we get actually minus 1 by 3 square cos 3x plus etc. Okay. But here we don't have any cos function. We don't have any cos function. I required 1 by 1. Instead of minus, I want plus. Instead of minus, I want minus. The rest of thing is okay. But I try to convert this cos function must be equal to 1. This cos function must be 1. I try to convert this cos function must be 1. Now, based on that, we have to choose the value. Now suppose put x is 0. Before going to put x is 0, observe in the given interval definitely x must 0 is must be included because of what is our interval? Minus by 2 pi, definitely 0 in the range. Once you put x is 0, what happen here? Definitely we get this must be becomes 1. But still I want plus minus. You have negative sign outside. Once you take negative sign inside, this become plus, this become minus. That gives rise your required result. Therefore, no, this is a way. Once you construct the Fourier series, after that you compare that series to the required deduced part and then choose the particular value. Try and error. You don't have any particular method to choose the value for to deduce part. Okay. Now we are going to put x is equal to 0. Put x is equal to 0 in the above expression. The above expression we get what we get actually we get f of 0 equals minus summation n ranging from 1 to infinity minus what about minus 1 to the power of n. See, observe, suppose put x is equal to 0. Now here, what happened? Put x is equal to 0. Now we get, what we get actually? Minus 1. I think is clear. Minus 1 to the power of n divided by n square. Cos 0 is 1. You already know that. What's the cos 0 value? 0. The cos 0 is 1. Okay. In the next step, I want to find out what is my f of 0. You have, what's the function you have? You have a function f of x is just now already written on the board. F of x is pi square by 12 minus x square by 4. What is my f of 0? F of 0 is nothing but pi square by 12. Okay, fine. Once you put a pi, now here we get pi square by 12 is my f of 0. Just now we calculate because x is 0. Now once you expand the series, what happened? Minus 1 by 1 square. Now put n is equal to 2, minus 1 whole square is plus 2, 1 by 2 square. Put n is equal to 3, minus 1 whole cube, minus 1 by 3 square, plus what about that, 1 by 4 square, minus etc. You multiply the minus sign, what we get actually pi square by 12 is equal to 1 by 1 square, minus 1 by 2 square, plus 1 by 3 square, minus 1 by 4 square, plus etc. This is where we are expecting the deduced part. If you want to observe the problem. Now, after once you construct the series, if you want to write is the required f dot s means Fourier series for the given function over minus pi to plus pi, if you want to write like that. Now, this is a way to do the deduce part. I think you're clear how we have to choose the value of x. Is vary from one problem to another problem. What you are expecting in the problem, based on that we are going to choose the value. Just zoom out the problem. My aim is the students, then I know this is a very small one. Now is why I did like that entire problem you have look like this. How to write the solution is in the form of second case is a function is an even function. First you construct the what about that Fourier series for the given function. After that I have to deduce. How to deduce that I already explained. What are the measures I have to take or what are the care I have to take. I already explained that part. Similar way I have to do it and then we get a final answer. Yeah, if you want I'll show it once again for in a zoom in. Yeah, this is a way to prove that for finding a0, an, you must be pakka with integration. While applying the upper and lower limit, product of any one of the function, you have sine or cos. First you find out corresponding upper and lower limit. Is 0, directly you write it 0. It's not 0, apply each and every, instead of x, the upper and lower limit. Now this is a way to find out the solution. This is one of the problem they given in the question paper. Okay, I think everyone is clear for this. Now I move to the next problem. Okay, now that is one of important problem. Now here over the interval 0, 2 pi. Before moving to the next problem, now second problem. Yeah, I move to the second problem. Second problem. Yes. Find the Fourier. I'm going to write f dot s. Don't confuse Fourier series for the function f of x equals x into 2 pi minus x over the interval 0, 2 pi, and hence deduce that pi square by 12 equals summation in ranging from 1 to infinity minus 1 to the power of n plus 1 divided by n square. Deduce part is not given in a question paper or model paper, but there is also a deduce part also very important. Now deduce part we'll do it later, but first try to know expansion of Fourier series for the given function. Now solution, what is the given function here? Given f of x is, you multiplied by x, what we get actually 2 pi x minus x square over the interval, what is the interval? 0, 2 pi. Yeah, start from 0, refer to which case for our what we discussed in the last two classes is nothing but first case 0 to 2l. Whenever the interval is in the form of first case, you don't have a rights to go for even or odd. Immediately find out the value of L. 2L is equal to 2 pi. What is pi L value? Pi. Once we get pi value, immediately we get what is n pi x by L. What is n pi x by L is nx. Yeah. Then we have to construct the Fourier series. Now Fourier series, just don't write f dot s, you please write what's the Fourier series expansion. Fourier series for f of x. This is not standard abbreviation. While writing in your notes, you please expand Fourier series for f of x over 0, 2 pi. Yes. F of x equals a naught by 2 plus summation in ranging from 1 to infinity an cos nx, and then summation in ranging 1 to infinity bn sin of nx, where what is my a naught formula? A naught formula is 1 by pi, because first case 1 by L, 1 by pi 0 to 2 pi f of x dx, and then an is what actually? 1 by pi 0 to 2 pi f of x cos nx with respect to x, and also bn is nothing but 1 by pi 0 to 2 pi f of x sin nx with respect to x. Okay. Now as usual, I have to find out the values of a naught, an and bn with help of the given function. Yeah. The next is actually I have to find out a naught. What is my a naught? Is 1 by pi 0 to 2 pi. I'm explaining how the even though it's a complicated function, how they easily have to find out 2 pi x minus x square with respect to x. 1 by pi is a constant. 2 pi is a constant for the first term. What is integration of x with respect to x? X square by 2. 0 to 2 pi. minus what is integration of x square x cube by 3, what's the limit? 0 to 2 pi. Yeah. Now here observe carefully. Now here 2 to cancel. Okay, fine. Once this 2 and also this 2 is cancelled. Okay, fine. Now while move to the next step 1 by pi. Yeah, pi is a constant. Keep outside. Apply the upper limit. 2 pi whole square. 4 pi square. Lower limit is 0. Similarly, keep the constant 1 by 3 outside. Apply the upper limit. What's upper limit? 2 pi whole cube means what? 8 pi cube. 8 pi cube. Okay, fine. In the next step, this is nothing but actually 1 by pi 4 pi cube minus 8 by 3 pi cube. Now, 4 by, now we take a common factor is what actually? 4 pi cube is a common from these two terms by pi. What's the remaining? 1. 4 you already taken. 1 minus 2 by 3. 1 minus 2 by 3 is nothing but what actually? 1 by 2. Yes, see, 1 by 3, sorry. 1 minus 2 by 3. 1 minus 2 by 3, take LCM. 3 minus 2 by 3 is 1 by 3. What we get actually? Pi is cancelled with pi cube. 4 pi square by 3 is the answer. 4 pi square by 3 is the answer. Next, similarly, I have to find out an and bn. What is my an formula? You already know that. An is nothing but I use some different color, easy to identify. 1 by 5 pi 0 to 2 pi 2 pi x minus x square into the function. What is function? Cos nx with respect to x. You go for here uv rule. While taking uv rule, this is u function, this is v function. Okay, fine. Now, from the uv rule, 2 pi x minus x square into what is integration of cosine nx by n minus what is differentiation of this 2 pi differentiation of x with respect to x1 minus differentiation of x square is 2x. X square is 2x. Into again I have to integrate this. What is integration? Minus cos nx by again the quotient of x is n into n is n square. Integration of cos is sine. Integration of sine is minus cos plus plus find out derivative of this. What is derivative of constant? 0 minus 2 into 1. Again I have to integrate. What is integration of cos is sine nx by another n, we get n cube. Then I have to stop because we get a constant. What about next higher derivative? Is a 0 to 2 pi. Now apply the what about that upper limit and lower limit. Yeah, better to keep the entire thing using the square bracket. Okay. Now 1 by pi is a constant. While applying the upper and lower limit, I'll keep the constant 1 by n. I told number of times is a product of two functions. This is one function, this is another function. One of the function is sine. Better I to apply upper limit. What is upper limit? Sine of 2n pi. What is sine of 2n pi is 0. What is sine 0 is 0. The product must be 0. The entire value must be 0 only. 0 minus 0. Okay. And then now minus into minus plus. Okay, minus into minus, what we get actually? Plus we get. Once we get a plus, keep 1 by n square outside. Apply the upper limit. What is your upper limit? Upper limit is what actually? My 2 pi. Once you apply the upper limit, now what we get actually now? Now we get 1 by, now apply the upper limit. Now what is the upper limit is 2 pi. Once you apply the upper limit, cos of 2n pi. What is cos of 2n pi value is 1. It's already I told minus 1 to the power of 2n. I discussed in my third class. Minus 1 to the power of n is 1. What is cos 0? 1. Therefore, here we have to apply carefully upper limit. What is my upper limit here? 2 pi minus 2 into 2 pi. 2 pi minus 4 pi. What's the remaining? Minus 2 pi. 2 pi minus of 4, 2 into 2 pi is minus 4 pi. We get minus 2 pi of cos of 2n pi. What is cos of 2n pi? Value is 1. Minus lower limit. What is my lower limit? Is x is 0. Most of the students are doing mistake. X is 0, enter 0. No, this x is 0 means which one is remaining? 2 pi. 2 pi into cos 0. What is cos 0? Is 1. While come to the next term, plus minus into minus, plus 2 by n cube, entire thing is 0 because sin 2n pi is 0, sin 0 is 0. Now what we get actually after the simplification? Minus 2 pi, yeah, 1 by pi of minus 2 pi minus 2 pi. Now we get minus 4 pi by n square. After the simplification, what do we get? Minus 4 by n square. Minus 4 by n square is the value of an. Please observe carefully. Is already written cos 2n pi value. That's why I written directly is 1 here. Now here, once you see minus 2 pi minus 2 pi minus 4 pi into 1 by n square, whole multiple of 1 by pi. Now finally we get an equals minus 4 by n square. Now I told number of times before moving to the next step, for what value of n is 0, n square is equal to 0, n is 0. But our summation start from 1 to infinity. Therefore this is confidently say that is true for n is equal to 1, 2, 3, etc. Suppose any value of n 1 to infinity is 0, denominator is 0, we get infinity. Such a particular value of n I have to find out separately. Further problem I am going to explain. Okay. Now move to next finding the value of Bn. Bn equals 1 by pi of 0 to 2 pi 2 pi x minus x square into sin nx. You go for which rule? UV rule or Bernoulli's rule. This is u function, this is v function. From the UV rule, what we get? 1 by pi of first function 2 pi x into integration of the second. What is integration of sin? Minus cos nx by the quotient of x is n minus what is differentiation of this 2 pi minus 2x. Again I have to integrate. What is integration of cos? Is minus sin nx by n into n is n square plus differentiation of constant 0 minus 2. Again integrate for this minus into minus plus. We get integration of sin. What we get actually? Cos of nx by n cube. Okay. Now you already know that the previous in an we already know that sin 2n pi is 0, sin n pi is 0. Observe carefully. In the second term, the product of two functions, one of the function is sin, but we already verified in the previous an, sin of 2n pi is 0, sin 0 is 0, the entire product must be 0. No need I to carry for that. This is the easiest way to find out the value of the limit after once you apply the UV rule. Now while applying the upper and lower limit, keep the constant outside. Minus 1 by n is a constant. Apply the upper limit. What is the upper limit here? 0 to 2 pi is the limit. What's the upper limit? 2 pi. Cos of cos of 2n pi is 1. 2 pi into 2 pi is 4 pi square minus 4 pi square. We get 0 actually. 4 pi square minus 4 pi square into 1. Minus x is 0 means this factor is 0. 0 into x cos 0 is 1. Okay, fine. Move to the last one. Plus into minus is minus 2 by n cube. 2 by n cube of cos of 2n pi is 1. Cos 0 is 1. Observe carefully. This is also 0. This is 0. This also must be 0. What happened? Entire Bn is 0 for n is equal to 1, 2, 3, etc. Bn is 0. Then we have to construct the Fourier series. Even though if look like a function is very complicated, this is the easiest simple way I have to solve the problem. Now I have to construct the Fourier series. What is my final Fourier series for the given function x into 2 pi minus 2 pi minus x over the interval 0 to 2 pi is a naught. Just now we calculated what is my a naught. What is my a naught is 4 pi square by 3. What is a naught by 2? 4 is cancelled with 2. What's the remaining? 2 pi square by 3. And then while taking an value, which one is constant? Minus 4 is constant. I'll keep it outside the summation. Either you take inside the summation or keep the outside the summation, does not matter. Answer must be same only because 4 is a constant. Minus 4, 1 by n square cos of nx. This is a Fourier is the required Fourier series for the given function over the interval 0 to 2 pi. Yes. In the next step, I already written one thing. I want to deduce one result. What's the result here? I want to deduce this. I'm going to write once again deduce part in the right side corner. The deduce part is pi square by 12 equals summation n ranging from 1 to infinity minus 1 to the power of n plus 1 divided by n square. I want to prove this result. You compare this result to this result. In this result, they have minus 1 to the power of n. You please try to observe this. This is having, if you want minus 1 to the power of n plus 1 can also be written as minus of n ranging from 1 to infinity minus 1 to the power of n by n square. Yeah. Minus 1 to the power of n plus 1 can also be written as minus 1 to the power of n into minus 1. Now I take minus n outside. You compare this to this. They have minus 1 by n square. Instead of cos nx, what you have? Minus 1 to the power of n. For what value of x? Cos nx, what we are expecting? Cos nx must be minus 1 to the power of n. Please observe carefully. Instead of this, what we are expecting? Minus 1 to the power of n. 1 by n square is there, same thing. Now for what value of x, give rise minus 1 to the power of n. You already know that x is equal to pi. Once you put x is equal to pi, cos n pi is equal to what? Minus 1 to the power of n. And you can't take directly x is equal to pi. You already know that what is our function they given? X into 2 pi minus x over the interval. What's the interval they given here? 0 to 2 pi. Yeah, definitely pi is in the range 0 to pi. Then we free to take. Keep in mind, you can't take simply any value for x. That value of x must be there. That value of x must be involved in the given interval. 0 to 2 pi is having pi value. Therefore, pi belongs to the given interval. Once you choose the value of x, first verify before going to put the value of x whether it's in the given interval or not. Is in the interval. Therefore, we are going to put x is equal to 0. Before going to put x is equal to 0, if you want to write what you written on the board, this is the required Fourier series for the function, for the given function over the interval 0 to 2 pi. You already written. Therefore, put x is equal to 0 in the above expression. We get, okay, we get what we get. F of 0 equals 2 pi square by 3 minus 4 summation n ranging from 1 to infinity 1 by n square minus 1 to the power of n. I want to find out what is my f of 0. Put x is 0. Put x is 0. What happened now here? F of 0 is 0. 0 into 2 pi minus 0. 0 into 2 pi is 0 only. Therefore, this is what we get actually 0. I'm going to write it here only 0. And then move to the this one. Uh, Actually, what they given to put x is equal. Don't put. See, I put x is equal to 0. It's not. Sorry, I did mistake here. Not for x is equal to 0, right? X is equal to pi. We discuss here x is equal to pi, right? It's not x is equal to 0. Okay, fine. Just a minute. Yeah. Don't confuse. Yeah. Put x is equal to pi. Yeah. Already I verified for which value of x we get cos n minus 1 to the power of n, x is equal to pi. Wrongly I substitute x is equal to pi, I have to substitute what we get minus 1 to the power of n. You don't get it, cos 0 is 1. You don't get it for x is 0. Once you put x is equal to pi, for this, what is f of pi? What is f of pi? Pi into 2 pi minus pi. What we get actually? Pi square. The value is pi square. Yeah, this f of pi equal to this. What is f of pi is pi square. What we are going to do here, pi square minus 2 pi square by 3 must be equal to minus 4 into summation n ranging from 1 to infinity 1 by n square into minus 1 to the power of n. Now I have to simplify for this. I have to simplify for this. Take LCM in the left hand side. Pi square minus 2 pi square. Take LCM and simplify. What we get actually? Pi square by 3. Once we get pi square by 3, you take 4 as a cross multiplication. What we get? 3 into 4 is 12. Pi square 12. You take minus n inside the summation 1 to infinity minus 1 to the power of n plus 1. Just few minutes before I explained. Minus 1 to the power of n plus 1 can also be written as minus 1 to the power of n into minus 1. Okay. Now this is our required result. Sorry, I did mistake. Not for x is 0, x is equal to pi. Now again I have to zoom out little bit. Then easy to get entire function in one screen. But I know it's a very small one. Now here this is a thing. I have to solve the function is in the form of x into 2 pi minus x over the interval 0 to 2 pi. Yeah. And now I'm going to zoom in little bit. Is okay. Observe carefully for this. Yeah. Yeah. Now again I'm going to recall for that what are the steps I have to follow for. So suppose the function is in the form of 0 to 2 pi. Yeah. Okay. Yeah. Now in the Fourier series, I have to expand the function is what actually x into 2 pi minus x over the interval 0 to 2 pi is in the form of first case, can't go for even or odd. Directly, I have to take the value of L. How to take the value? Compare upper limit of the given interval to upper limit of the first case. 2L is equal to 2 pi, we get pi. You construct, you find out A0 and AN and BN. While applying upper and lower limit, especially for A and BN, product of any one of the functions sin or cos, first you verify that corresponding limit is what happened. Lower and upper limit. Any one of the functions, sine or cos is 0, product must be 0. You neglect it. Similarly, find out Bn also. After that, we construct the Fourier series. Once you construct the Fourier series, I compare this result to the required result. The required result for my convenient can also be written as minus of n ranging from 1 to infinity minus 1 to the power of n by n square. Once you compare that and take the value of x, 1 by n square minus n is there, n ranging from 1 to infinity. Don't worry about the constant. Just observe the inside the summation. Instead of my cos ns, I want minus 1 to the power of n. What we are going to choose? Pi. Pi definitely in the range 0 to 2 pi. Definitely now I'm going to put x is equal to pi. But wrongly I identify correctly, but while doing that wrongly I taken 0, sorry. That is x is equal to pi. I have to put x is equal to pi in the above expression. We get pi square. Because x is equal to pi, what we get? F of, now I have to put x is equal to pi here. Once you put x is equal to pi, now pi into 2 pi minus pi we get pi into pi is pi square. You substitute pi square and take constant term one side, take LCM for this simplification. I skip one simple step, I'm agree for that because this is very simple. While simplification of this, what we get actually 3 is LCM, 3 pi square minus 2 pi square. What we get actually, this must be equal to pi square by 3. Yeah, you have pi square by 3. You take 4 as a cross multiplication. Yeah, you take it 4 as a cross multiplication. What we get? Pi square by 12 is equal to 8 by this summation. Pi square by 12 is summation in ranging from 1 to infinity. I take minus n inside the summation, minus 1 to the power of n plus 1 divided by n square. This is a way to prove the deduce part. Deduce part, you don't have any method. You compare, once you construct the Fourier series, compare and choose the suitable value. That value must be in the given limit. Otherwise, you can't substitute that value. Why? Because function is not defined that value. Function is only defined in which interval 0 to 2 pi. Other than 0 to 2 pi you are taking, function is not defined, how can you have to choose the value? Function is not defined means we can't find out the value of x at that point. Thank you very much for listening this class. I will come and meet in the next class with some more problem. Take care. Bye.